phone's camera takes about 30 photos per second. But here's the wild part. It doesn't actually see any of them the way you do. Right now, somewhere in a data center, an AI is looking at a picture of a dog and has absolutely no idea what a dog is. It's just looking at numbers, millions of them. So how does it go from just numbers to understanding that there's a golden retriever in your photo? That's what we're breaking down today. And by the end of this, you'll know exactly why Vision AI sometimes gets things hilariously wrong, and why it's getting terrifyingly good. Let's start at the absolute beginning. When you take a photo, your camera captures light. That light gets converted into pixels, tiny colored dots. Each pixel is just a number. Red might be 255, green might 120, blue might 45. A full 1080p photo? That's over 2 million pixels, times 3 numbers each. So you're already looking at roughly 6 million numbers before the AI even wakes up. Here's what most people don't realize. Vision AI never actually looks at the photo the way you're looking at it right now. It doesn't see the big picture first. Instead, it processes those millions of numbers through something called a neural network. Think of a neural network like a factory assembly line. Raw materials come in one end. That's your pixel numbers. They get passed through different stations, transformed at each stage, and by the end, you get a finished product. The first layer of the network is obsessed with simple things. Edges, corners, lines. It looks at nearby pixels and asks, do these numbers change suddenly? If they do, boom, there's probably an edge. The second layer takes that data and builds on it. Now it's not looking for just edges. It's looking for combinations of edges. Curves, circles, textures. By the third layer, something cool happens. The network starts recognizing things that are way more complex. Ears, noses, eyes. These layers are combining all that earlier information, edges, textures, shapes, into actual object parts. And this keeps happening, layer after layer, deeper and deeper. Some of these networks have over 150 layers, each one building on the last. By the time you reach the final layers, the AI isn't thinking in terms of pixels anymore. It's thinking in terms of concepts. Is this a dog? A cat? A person? It's made a decision. Now, here's where it gets interesting. None of this is programmed. No engineer sat down and told the AI, hey, ears look like this. The AI figured that out on its own. This is called training. Researchers show the network millions of photos labeled with the right answers. This is a dog. This is a car. This is a person. The AI adjusts itself, tweaks the math in each layer to get better at the task. It's not memorizing. If that were the case, it would only recognize the exact photos it saw. Instead, it's learning patterns, universal patterns. So when it sees a dog it's never seen before, it recognizes it because it understands what dogness looks like in number form. But here's why Vision AI can be hilariously bad sometimes. It doesn't actually understand the way you understand. It's playing pattern recognition at superhuman speed, but it's missing context. Show it a panda in the snow, and it might say, that's just white. It doesn't know that snow is background, and the panda is the subject. Show it a dog and a cat both in the same photo, and depending on how they're positioned, it might focus on one and completely miss the other. There's this famous example. AI trained to recognize dogs would sometimes identify a dog based entirely on the grass it was standing on. Not the dog itself, just the grass. Researchers figured this out and had to retrain it with dogs on different surfaces. So why is Vision AI getting so scary good? 3 things. 1. More training data. 2. Bigger networks with more layers. 3. Smarter architecture. GPT-4 Vision, for example, which is one of the most advanced vision AIs right now, was trained on a dataset so massive that I literally can't tell you the exact number. But we're talking hundreds of millions of images. On top of that, researchers have figured out smarter ways to build these networks. Techniques like attention mechanisms, basically telling the AI to focus on the important parts of an image while ignoring noise. So what does this actually mean? Well, your phone's camera app now understands what you're photographing in real time. It can tell when you're taking a portrait and adjusts lighting automatically. Security cameras can alert you when there's a person in your driveway. Medical AIs can spot tumors in X-rays that human radiologists miss. And that's just the start. As these networks get bigger and smarter, they'll get faster and more accurate. The trade-off is they're harder to understand. Even researchers building these things can't always explain why the network made a specific decision. It's like asking a human, "Why did you recognize your friend?" You just did. You saw their face. But if I asked you to explain every detail of your face recognition process, you couldn't. Same thing here, except the AI is making decisions based on millions of numerical parameters instead of something we can put into words. The bottom line, Vision AI doesn't see the world. It decodes it. It turns light into numbers, processes those numbers through layers of mathematical transformations, and outputs a guess. A really, really good guess, but still a guess based on patterns, not understanding. And knowing that changes how you think about it. It's powerful because it's accurate, but it's also fragile in ways you might not expect. And if you want to try any of the tools mentioned in this video, I've linked everything in the description below. Vision APIs from OpenAI, Google, and others are actually pretty accessible these days if you want to experiment. Drop a comment if you've seen Vision AI do something wild. And if this breakdown made sense, subscribe for more videos that explain how the tech actually works under the hood. Thanks for watching.